All right, guys, welcome to 11.7 notes completion. And here we talk about cones. And again, we are just focusing on the volume of the cones this for this quiz, and not the surface area. So that's why these notes are just volume and all things voluminous. All right, in class we had a little demonstration about filling up a cylinder with 3 cones of the same radius, circular base, and the same height. And that lends us to the 1/3 concept from our formula today. So just like pyramids with prisms, cones and cylinders follow the same 1/3 relationship. The nice thing about the cone is that the base is always a circle. So it's instead of 1/3 BH, like the pyramid, because the pyramid could have, all kind of polygonal bases. A cone will always have a circle base, so big B is always pi r squared. And oblique follows the same rules as a right cone. All right, first problem. Here's just basics, guys. Here's the height, here's radius, plug it in, get familiar with the formula. So again, our formula is 1/3 pi r squared h, 1/3 of the cylinder that it would have encompassed. So just plugging things in, 1/3 pi 2.2 squared times 4.5. All right, so multiplying this all out in your calculator, and you get about 22.8 cubic centimeters. Right, doesn't get much easier than that. All right, now they're definitely going to hit you with the similarity in this section as well. So cones A and B are similar. Find the volume of cone B. So now, what is our link? Our linear ratio here is we have the radius of each. So we can't just straight up find the volume of this one on the right because we don't know the height of it. But we know the volume of something similar, so we can do it. So the similarity ratio or scale factor is 1:3. So the radius triples, but the volume doesn't triple, right? It's in cubic units, so we have to cube this scale factor. So now 1:27. So if our volume, or if our sides or radii get 3 times bigger, then our volume is going to get 27 times bigger. All right, so cross multiplying, and we get 405 pi's as your volume, and that's in cubic feet. So feet cubed. And you could multiply it out if you want. Doesn't really specify in the direction, so you could answer it as 405 pi or multiply that out and get a decimal answer. All right, pause the video here, give this one a shot, composite solid, and we'll see what you come up with. All right, now in this one, we have a cylinder with a cone on top of it. And the heights are different, but the radii would be the same basis with these things. So the cylinder's volume, of course, is pi r squared h, and the cone's is 1/3 pi r squared h. So just plugging things in, you get pi 6 squared times 5 for the cylinder, and then 1/3 pi 6 squared times 4 for the cone. Simplifying this in terms of pi, that's 180. 36 times 5 is 180 pi's. Over here we have 36 divided by 3 is 12 times 4, 48 pi's. So altogether you've got 228 pi's. 228 pi's, which in your calculator is approximately 716.3 cubic meters. All right, guys, so that is a wrap. And then just be aware too, like you might have to back solve this formula. They may give you the volume and ask you for the radius or the height So if that happens, just plug things in and be able to back solve. And that is a wrap, guys. So that's 11.7, a quick volume lesson on cubes. Peace.